Hey everybody, welcome back to Stats Learning Cards. Yay! Anyway, to avoid some confusion, I'm going to call this, since we're starting second semester with this, I'm going to call this card 2-1. I know some of you guys think it's 10, some of you guys think it's 15. According to my list of some of the stuff that we skipped, it's actually number 29. So we're just going to start off and start fresh. So, learning cards. So we're talking about binomial distributions up here today. And down here, for some reason the title didn't come through on the card. We'll call it binomial settings. But anyway, so now that we got that out of the way, let's talk about this. And we did an introductory activity on this. So some of this is going to seem kind of familiar, hopefully. But we want to have something so that you know, is this a binomial setting? You've got some characteristics for it, etc. So if you use the acronym SNAP, that will go ahead and help it. So the S stands for success and failure, or success/failure. And you only have two options. It's the only two options for each observation. I'm going to move that down over here. So every observation that we do either succeeds or it fails. That's it. There is no other possible option for what could happen. N stands for, that N is the number of observations that we have. So wherever you see an N, that's the number. It's a fixed number. It's a fixed number of trials. Probably should have done this last part in black. It's amazing what happens when you pause things. Oh man, I blew. I tell you, see, the magic of the internet. That's why you double check things before you turn them in, people. Anyway, so all of the events are independent. And so again, that means that one thing doesn't affect the other. And then P stands for the probability of success. And that is each trial has to have the same probability. All right. And again, obviously pause wherever you need to. And before I forget, hit that like button and don't forget to subscribe. All right, so the notation for a binomial setting is b comma n comma p. So for example, b 7 comma 0.5. Okay, and so this means that you have a binomial distribution, is the big part, is the b. With, you have a total of n observations, and again, you know that from the SNAP, where each has the probability p of a success. All right, so let's do an example. Actually, we're going to write out the binomial formula first, and then we'll show you an example. So up over here, binomial formula. So we're going to leave a little bit of room here so we can define things. So I'm going to go down here, and we're going to have P of X is equal to K. And that's going to equal the combination of n over k, and we'll talk more about that. We talked a little bit about that last week. If you ended up taking pre-calculus, you may have seen that. Then you're going to take the probability to the k power times 1 minus the probability to the n minus k power. So again, remember, n is the number of trials. So that means that k equals number of successes, which means that if I take k away from the number of trials, if k's are the successes, remember back over here, okay, we either have success or failure. So if k is the number of successes, then n minus k has to be the number of failures. And likewise, P is equal to your probability of success. So since you're only successing, good job. Since you can only be successful or fail, if P is the probability of success, then 1 minus P is going to equal your probability of failure. Now again, as I said in class, the one thing you do have to remember is that success and failure is not necessarily meaning the positive. Success is not always the positive outcome in terms of what's going on. If you're talking about saying there's a 10% chance of dying, that could be your success. Okay, so you kind of have to be, don't automatically think success is going to be the positive outcome of what's going on. It's whatever you're looking for. The failure is whatever is the opposite of that. And as we get more into things, that'll make more sense. All right, this n over k, remember that's the probability, that's the combination. And on your calculator, it's going to look like this. And choose R, or NCR. Use a calculator to find the number of combinations of 6, So you enter 7, math, go to probability, NCR, enter 6, and then you press enter. And this, okay, so to do that, you're going to go here. So if I were going to do, so going back to this problem here, let's say if I wanted to know, again, using the binomial distribution that we had here, of the 7 trials with a 50% chance of success, let's say we wanted to figure out the probability of having exactly 6 successes. So the first part is we need to go 7, choose 6. And then we're going to multiply that by the probability of success raised to the 6th power. And I'm going to go ahead and write this out. In practically speaking, when you're writing this down, obviously you can go 1 minus 0.5 in your head and get 0.5. I'm writing this down because, again, remember, when you're looking back at this, you want to be able to say, how did I come up with that? So the probability of success, 0.5, raised to the number of successes, 6, times the probability of failure, which is 1 minus 0.5, raised to the number of failures that we have, which is going to be 7 minus 6. So then this, over here, remember, we're going to stick into our calculator, and it's going to be 7, choose 6. And that's equal to 7. So then this whole thing here is going to turn into 7 times 0.5 raised to the 6th power times 0.5 raised to the 1st power. And yes, before you ask, if you want to type that in on your calculator as 7 times 0.5 to the 7th power, go for it. So anyway, here we're going to get like 0.0547. And again, 4 places is usually a pretty good standard way to go. Okay, so that's the basics of binomial settings. That should get you at least started on some of the stuff. We'll do one more card talking about like the cumulative distributions, and then get into some of the geometric stuff. See you back in class. And don't forget to hit the like button and subscribe. Talk to you later.